All right, this is lesson 2.11 of our calculus class. Unit 2 is called derivatives. Lesson 11 is called derivative from a graph. This lesson is kind of a side lesson. The goal of this lesson is to really practice our understanding of the product rule, the quotient rule, and the chain rule. So can you read the graphs to find these derivatives? This is also going to test your understanding of derivatives as being the slope of a tangent line. So we'll look at that in a minute here. So here's the rules we're going to use for this lesson. All right. So if I define h of x as a function that's equal to f of x times g of x, and I want to find h prime of negative 6, and f of x and g of x are defined as the graphs shown here, I need to know, I'm taking a product of functions. So I'm going to use the product rule for derivatives. Product rule is g times f prime plus f times g prime, or low d high plus high d low. And I need to identify g of x, or g of negative 6. I need to find f prime of negative 6, f of negative 6, and g prime of negative 6. Okay, so if I look at f of negative 6, I can just read the graph. X equals negative 6, y is going to be positive 4. So f of negative 6 is 4. Now f prime of negative 6. Let's talk about what that means right there. F of prime of negative 6 means what is the slope of the graph when x equals negative 6. So if I find x equals negative 6, this point right here, what is the slope of the graph at this point? Well, we have a section of a line, so the slope of this line will tell us f prime at negative 6. So we can see we go from negative 7, we go up 3, oh, my mouse went away. From negative 7 to negative 6, we go up 3. So up 3, right 1 is the slope of our line at negative 6. So we can say that f prime of negative 6 is up 3, right 1, or 3 over 1, which is just 3. I think when I explained this in class, 6 over 2 came from the whole line. So if the whole line from negative 6 to negative 5 is up 6 and right 2, then up 6 and right 2 is really the same as going up 3, right 1 twice. Up 3, right 1, up 3, right 1. So either way, f prime of negative 6 is 3. And that really, hopefully that pounds in our definition of derivative for you. Okay, so we also need g of negative 6 and g prime of negative 6. G of negative 6, that's right where x equals negative 6 is where g crosses the x-axis. So g of negative 6 is just 0. G prime of negative 6, well, the slope of this line, this section of the line right here on a graph of g of x, the slope is negative 1. So go down 1, right 1 for this segment. So g prime of negative 6 is just negative 1. So if I plug in f of negative 6, f prime of negative 6, g of negative 6, and g prime of negative 6 into our product rule, I'm going to get 0 times 3 plus 4 times negative 1. And if I do the calculations, I get 0 plus negative 4, which is just negative 4. So to answer our question, h prime of negative 6 is negative 4. Boom. All right, next example. H of x is a function defined as f of x divided by g of x. We're going to find h prime of negative 6 now. Well, this is the same graph as before, so we can reuse our numbers for the last example, and we're still finding negative 6. So f of negative 6 is still 4, f prime of negative 6 is still 3, g of negative 6 is still 0, and g prime of negative 6 is still negative 1. So if we do the h prime of negative 6, we are going to do our quotient rule, which is g times f prime minus f times g prime divided by g squared, or low d high minus high d low over low squared. And we're going to plug in our different values into our quotient formula. We're going to get 0 plus 4 over 0, or 4 over 0. And 4 over 0 is Can't divide by 0, so that means the limit does not exist. So we got a vertical asymptote or something there for h of x. Let's see here. Next one, so if h of x is defined as a composite function, f of g of x, now we're going to find h prime of negative 7. So the graphs for this one are the same, but we're looking at a different input value. So I need to re-identify my f, f prime, g, and g prime at negative 7. So if I look at f at negative 7 equals 1. If I look at f prime of negative 7, what does it equal? Well, if we look at the left side, our slope is down 3, right 2. So the derivative as we approach negative 7 from the left is negative 3 over 2. But if I look at the right side as we approach negative 7 from the right, we have a up 3, right 1. So we have the derivative as we approach negative 7 from the right is 3. So because the derivative as we approach from the left is not equal to the derivative as we approach from the right, then we say our derivative does not exist. F prime of negative 7 does not exist. And at this point you might say, well crap, how do I use this rule if I don't know, or if f prime doesn't exist? Well, think about the formula for chain rule. Formula for chain rule is f prime of g of negative 7 times g prime of negative 7. So f prime is at negative 7 is not actually used. Negative 7 is going to go into g first. And so since, well, let's see here, g of negative 7 is going to be positive 1. So f prime of g of negative 7 is equal to f prime of 1. Well, f prime of 1 is right here. That's a slope of positive 1. Up 1, right 1, up 1, right 1. So f prime of g of negative 7 is equal to f prime of 1, which is equal to 1. I don't know why I put a 2 there. Let me think about that for a second. Yeah, it's definitely 1. That 2 should be a 1 right here. Okay, and so then g prime of negative 7. If we look at g at negative 7, we have a slope of negative 1. So g prime of negative 7 is negative 1. So for our chain rule, we multiply this by negative 1. And then we get 1 times negative 1. That should be negative 1. So the answer here should be negative 1. Don't know why I put a 2 here. That's beyond me. Crazies. Hey, so hopefully this lesson really helps you pound in the 3 derivative rules that we learned for this unit. Hopefully also it gives you a deeper understanding of what derivative means by looking at a graph.